Welcome to Simple Physics. In this video, you will learn about a few advanced effects of refraction. On a clear dark night, our eyes can see about 6,000 or so stars in the sky, each visible as a single dot. The light coming from each of these dots is in the form of a single ray that appears and disappears rapidly, along with a change in its brightness. This gives us a perception that stars twinkle. Let us now understand how this happens. The position of a star visible to us is an apparent position. This is because the ray of light coming from the star is refracted by the atmosphere. However, the refractive index of the atmospheric layers undergoes rapid variations on account of turbulence. Hence, the path of the ray of light coming from the star is continuously disturbed. This causes the star to appear and disappear from its apparent position, along with a change in its brightness, giving us a perception that stars twinkle. Planets are significantly closer to us than the stars, and the change in their apparent position is negligible. Hence, they do not appear to twinkle. Whenever the sun comes above the horizon, we say that it rises. However, the sun actually begins to appear to us before it has come above the horizon. Hence, we always observe an early sunrise. Similarly, whenever the sun goes below the horizon, we say that it sets. However, the sun continues to be seen even after it has gone below the horizon. Hence, we always observe a delayed sunset. Both these observations happen on account of refraction of light by the Earth's atmosphere. To understand this, consider viewing the Earth from above the North Pole. Despite being still in the darker half of the Earth, rays of the sun are able to reach place A on account of refraction by the atmosphere. When these rays are produced backwards, we find that the sun is seen at an apparent position that is higher than its actual position. What this means is that the sun appears to be already above the horizon, whereas it is actually still below the horizon, resulting in an observation of early sunrise. Similarly, on the other edge of the Earth, the sun continues to be seen above the horizon, even when it has actually gone below the horizon, resulting in an observation of a delayed sunset. Another common astronomical observation is that the sun appears bigger during the time of sunrise and sunset. This is again due to refraction of light. In the Earth's atmosphere, the layers closer towards the Earth are denser and have a higher refractive index, whereas the layers far above are less dense and have a lower refractive index. During sunrise and sunset, the sun is at the horizon, and the rays of the sun pass through a greater span of the atmosphere with a higher refractive index. This causes the sun to appear nearer, and hence, bigger. Nothing of this sort happens during noon, when the sun is overhead, since the span of the intervening atmosphere has a significantly lower refractive index. If an object is placed in front of a mirror, made up of thick glass, we would see a number of ghost images as well. To understand how this happens, consider a thick glass mirror whose lower surface is polished. When a ray of light enters the thick glass mirror, it is first refracted towards the normal, then reflected by the polished surface, and finally refracted away from the normal as it emerges out of the glass mirror. This reflection results in the formation of the brightest image. However, some part of the ray of light is reflected by the unpolished surface as well. This results in the formation of several ghost images that are fainter. Amongst all images, the second image is always the brightest. This is because it has been formed by the reflection of maximum intensity of light by the polished surface. And now, the summary of this video. Stars appear to twinkle on account of atmospheric refraction. Atmospheric refraction is responsible for early sunrises and delayed sunsets. The sun appears bigger during sunrise and sunset on account of atmospheric refraction. Refraction of light causes the formation of multiple images by a thick glass mirror. That's all about the common effects of refraction. In the next video, you will learn about The most fascinating effect of refraction, total internal reflection.